So I think part of the problem is that actually, I know part of the problem is that while I've been talking about writing code a whole lot, you haven't actually been taught how to write code, which you can't really do until we actually get into the weeds a bit. So there's two methods your book goes over that I would read, and I definitely read them because they're in your book, which is free, right? And it's 6.2 and 7.3, which we'll go ahead and go over. And this is one of the most common mistakes of beginners right over here. I mean, I've noticed it. Beginners, they try to write a lot of code before you even try testing it once. Now, I'm guilty of that mistake, but I'm not a beginner, and it just seems to just spit all out right now for me like I'm a veritable font of knowledge, which is not the case. It's just simply that I've done these little incremental kind of designs for a while. The other mistake I notice a lot is an over-reliance on scanner, because we use scanner in the beginning because we want to do input-output from the user, right? Because we want to get variables. But the reason we use scanner a lot of time is because we don't in the beginning is because we don't know how to use methods, and I don't want to throw methods at people too soon, because methods require knowing data types, and that can be then understanding how to pass in variables, and that becomes it becomes a whole. There's a lot of little steps that you have to do to be able to do that. So the other big thing is when I tell you to write a method, don't use scanner unless I tell you that the method, reads input from the user. Like if it's given something, then you're given it as a parameter. So this is how you should design things. All right. Start with a working program. Start with something that works. Your program should work at all times, right? That's one thing you may have noticed with my program. There's never really any, if I ever find any like red or errors on it, I immediately fix it. Or when I come over to you, if you've got a bunch of red all over, I either add the enough curly braces so that it works, or I just simply delete the offending section, right? I do that a lot, where basically if I see it's a mess of code, I just delete it. Because if it's not working, then because basically it's like a giant knot. You can't untangle it. You can untangle simple knots, but giant knots, they're not worth the time. It's better to try to just burn it all down and start that little section from scratch. So we start with a working program and make small incremental changes, right? That way, as soon as you crop up with an error, you know exactly where that error is. Okay, that's kind of the idea. Like, okay, it was working, then I made a change, now it's not working. Okay, so the change is guilty of creating this error. Another thing is to use variables to hold intermediate values. So if you're doing something where there's a calculation that takes step by step, do each step one at a time rather than trying to do it all at once. And I deliberately do this whenever I'm teaching, even though some students say, well, can't you have done this in one step? And I'm like, yes, very much so. But that's not the point. I want to be able to do it in small steps so that it's easier to read. Once it's entirely working, then you can make it simpler. But only if it makes it only if it still makes it easy to read. So the example given in the textbook that we're going to use is that we're going to want to find the distance between two. We want to find the distance between 2 points. So you're given, on the coordinate plane. So something you probably had to do in algebra plenty of times, right? x1, y1, x2, y2. Now the difference between here and the math class is that when I tell you when I want to do something mathematical, I give you the mathematical definition, and I tell you this is what you need to program, right? As opposed to telling you to remember what the Euclidean distance is, right? Because I could tell you that I want the Manhattan distance, which is where it's the x plus the y, just straight, just that, right? But here we're talking about the Euclidean distance, which, if you remember, possibly from math or from algebra, is you take the x coordinate and you subtract them from each other and square it. You take the y coordinates and subtract them from each other and square it. It doesn't actually matter if you do x2 or which one you subtract from which, so long as you're consistent about it, right? So, and then the negative numbers, since they're negatives, they'll be squared anyway, so that's fine, and that'll be positive. Like if these go below 0 and you square them, it's perfectly fine. And then you throw that into the square root. So so we want to write a method that does this. So the first thing you have to do is figure out what if I'm building a subprogram that does this, a method, what do I have to do to, what should that look like, right? Okay, well, we need the public, we need the static, right? Public so that everybody can find it, static so that I can, because that's the magic word I know I need right now. Distance is going to give me what back, you think? What should the output of this method be, right? Well, if it's the square root of something, it's probably want to be the double, right? Give me a double. Since if it's giving me a square root, that's probably going to have floating points in it, so give me a double, right? If it's a number, right, it's either essentially, most of the time it's either going to be, it's going to fall into one of two, for us right now, it's falling into one of two categories, a number or a string, right? And if it's a number, then we just simply one of three categories. So the first category is a number, the second category is a string, the third category is a boolean. All right? If it's a number, then we just have to ask ourselves, is it an int or a double? Okay? If it's a string, sorry? If it's a string, you just put string here. Void means nothing. Void means it doesn't return anything. It doesn't give you a value back. Okay. So int so if it's a number, we just got to figure out, is it a whole number or is it a double? If you're not sure, put a double, because all integers will get converted to doubles anyway, so that's fine. A double's safe typically. But if you know you need an integer, put an int. Okay? Otherwise if you need like a word or text, you're going to want to get a string back. And if it's telling you, like, if it's detecting if something is something or is not something, then that's a boolean. So we'll put boolean there. For distance, we're calculating a double. It needs a distance. And then we figure out what we need to calculate the distance. What needs to be provided to us to calculate this. And we need 4 coordinates, right? We need the double x1, double y1, double x2, double y2, right? The first point and the second points, right? And each point has a x coordinate and y coordinate. Now you could do that in x1, x2, y1, y2. There's nothing stopping you from doing that order. I just think the first pair, the second pair made more sense to me, right? Okay, so I already have an error because this is going to tell me that this is returning a double, right? I told this is going to return a double, but I'm not returning anything. So right now I'm just going to return 0.0 as a placeholder. This is what we call a method stub. And that's essentially the first thing you should write when you're writing a method. Why? Well, because if you write a method stub, then you've got basically the outline of your method working there. You've got the outline of a method. But unlike the outline of outline of, like, a paper you're writing, you can actually do something. I can actually call this, right? I can say double distance from 0, 0 to 1, 1, right? It's going to give me the wrong answer. So let's say double dist is equal to distance, right? It's going to give me the wrong answer. And again, those little faded gray text over here, x1, y1, that's just simply these are just simply helpers that IntelliJ provides to me to remind me what I'm matching up against, which I find really useful here in this context because sometimes the amount of text the source code I'm dealing with gets big. All right, but here the code, even though it's wrong, it's not giving me an error, right? That's kind of the point, right? Even though it's not working correctly, it's not broken. That makes sense to everybody? It's just returning 0 for the distance to everything. Okay, right? So that's what you should do for stubs. I typically like to do -1 or as a value, but they had 0 in the example. It's essentially a placeholder. So that way we can calculate. That way we can think if we need to, when you're breaking it down into a program into small parts, you can think about what placeholders you need. Okay? Right? Another thing you want to do is like figure out something that we'd want before. Like we'd want to know a known. When we test it, we want like a known answer. Okay. So for example, here we know that the answer would be 0, 0 to 1, 1. Well, that would be what? Actually, be the root of 2, which is a bit hard to calculate. So the example your book says to test was that why don't we do 1, 2 to let's see, to 4, 6. And the reason that they suggest that 1 to 2 1, 2 to 4, 6 is that that's, you know, your standard triangle that you get in geometry, where basically it represents this side of the triangle you'd get in geometry. You've got a 3, a 4, and so we know this distance is a 5. So the distance from here to here is a 5. This is the standard. These are those points on that standard triangle that we know from basic geometry. So the answer. So once we get 5 as our answer, we'd be good to go. But of course, we can't just put 5 here. That'd be cheating, right? So the next thing to do is actually to calculate the little bits of it, right? So why don't we? So first thing we have to do is calculate the distance between the x's and the distance between the y's, right? So let's do that. So right, it is right. We want to calculate this formula, but we don't want to do it all at once. We just want to, let's work from the inside parentheses to the outside parentheses. So dx, let's go with like a delta x, right? Distance between x. dx is equal to x2 minus x1, right? And then we need to square that distance, right? Well, that's the distance. That's what this distance is. And double dy. But we'll actually get there, right? You can jump ahead to that step if you're feeling confident. But for right now, we just want to make sure that our program's always working, right? Right? x1 minus y1, x2 minus y2 minus y1, x2 minus x1, right? And right now, those don't give us the answer, but we can add in system.out print line statements to make sure we're getting answers that sound consistent, right? So here I'll add in statements that say this: dx colon plus dx dy. Okay, and now we run this. It says the difference between the x's is 3, and the difference between the y's is 4. And that was so we had what variables? We had 4 minus 1, and we had 6 minus 2, so that makes sense, right? Okay, now we can go about squaring these, right? So how do I square them? Well, we can either multiply it against themselves, or we can do math.pow, which is the way to square things. And math.pow takes in 2 variables. The first is the base, and the second is the exponent. So if we want to square this, we go x2 minus x1 is equal to 2. Math.pow. And mind you, I'm making this small change, right? And I can just test this again. All right, so we had 3 and 4. We had 3 and 4. Sorry, we had 3 and 4, and now we have 9 and 16. And so let's just plug those in. If I do 9 plus 16, I'll get 25, and the square root of 25 is 5, which will give us our answer. So we're on our way to the right answer, right? See, I'm just building each part slowly, and that's annoying and boring, but if you're having trouble, it helps. All right, so the last thing I have to do is take the square root of those two things, of the sum of those two things. So double answer. I'll do A and S for our answer, is equal to math.square root of dx plus dy okay, and then I'll say, and then I'll print it out before I say it's ready. So ANS plus answer. Right, and I'll run this. So we got 5, which is the answer we expected. So now what I'll do is that now that I've got the answer that I'm working with, and I'm fairly sure I've implemented this, I'll return A and S, okay? And then I'll comment out all these print line statements since I no longer need them. And now I'll run it. And I got 5.0. Right? So it's just it's a slow methodical way, and it's kind of annoying to have to do it sometimes. But if you're having trouble, that's the way we break it down. And these things just work very fast. And you'll see that this is how they do it. They broke it down into doing d squared. So they did dx times dx plus dy times dy. So they got their 25 answer. And then they threw that into that. So there's different ways to do that. And the idea is now that by breaking it down into methods like this, you can use them more and more often. So we can use these to we can have methods that figures out the area of the circle, right? That will give us, so this is the x coordinate of a point of the center of the circle, and then a point on the perimeter of the circle. Calculate that gives that distance. It gives us the radius. And then we can calculate the area of a circle with that radius to get the area. And those just allow us to write those kind of methods. So I haven't gone over overloading. That's perfectly fine right now. So Boolean methods. So methods again. These are typical for doing testing that would like testing if something is true or not. Right, and typically they look like this. Public static Boolean is single digit, which is I think something I go on over the practice exam, right? Index, if x is greater than -10 and x is less than -10, then that's a single digit number, right? What are single digit numbers? They're numbers that are either 0 through 9, positive or negative. So if it's a single digit number, if x is greater than 10 and it's less than 10, so if both of those things are true, then it's a single digit negative. It's a single digit number. Otherwise, return false. It's common to give them give Boolean method names that are basically yes/no questions. Is it a single digit? Yes or no. What's cool is that though you can kind of disregard the whole if-else statement. You can instead actually just replace it with this, which I found another textbook calls it Boolean Zen, where basically you can just return this expression, because if it evaluates to true, you're returning true. If it evaluates to false, you're returning false. So in that case, why not just return the expression itself? Return what it evaluates. So that's pretty nice. So now let's talk about the way you build a program. Okay, so I went over some of this yesterday. Sorry, I scanned over this yesterday, and so anyway, so this is the section they call encapsulation and generalization. So this is another process for developing programs called which they call encapsulation and generalization. The steps are, we're going to write a few codes in main or inside of another method, right? So we build another method or we work inside main and then we test them. So in other words, we do what we were just doing over there, okay? When they're working, when you get them working, put them in a method and then test them again, right? So take the lines of code you just wrote, put them in a method, because now you've completed that subproblem, and if you think you need to reuse it, well, now that's a method, you can. And then if it's appropriate, you can change the literal values, the fixed values in the program with more general values, with variables and parameters, right? So the second step is called encapsulation, where basically we're just taking a little bit of code and putting it into a small method that we can reuse, and then we generalize it. So to demonstrate that, they've got examples that will display multiplication tables. So something we kind of did as exercise before. So here's a loop that displays multiples of 2 all on one line. Okay, and this will introduce a new print function that we haven't seen before called printf, which is possibly the oldest print functions of all. And there's a reason we didn't go over it, but it exists in pretty much every language. And it's very useful, and it's very old. So let's go ahead and paste this in. So int I is equal to 1. While I is less than or equal to 6, printf percentage 4d 2 times I is equal to I plus 1. And then print out a new line. So run this, and it prints out 4, 2, 4, 6, 10, 12. Now, printf is actually this really interesting thing. It's just a print line statement. And what it does is very, very, very interesting. So let me go ahead and get to the table of contents. Now, in C, basically, C only really has printf in it. If you want to print characters, let's see, go to settings, view. Kinda. It allows you to put stuff in there, and it also allows you to do what it is for formatting. So let's see. Where is it in here? So, right, if we were to use, if you use a double, it can display up to 16 decimal places. So if I did 0.4 divided by 0.3, let me go ahead and use this. So this is a nice feature that they added in. 4.0 divided by 3.0. That's a lot of extra, a lot of extra, threes that we don't necessarily need there. So what you can do for printf is you can print formatted. 4/3 is equal to %, 0.3f. So the value in the parentheses is the string you want to specify how your output gets displayed. And it contains a bunch of ordinary text, and then it's got what's called the format specifier. So %, 3.3f indicates that you should display it as a floating point notation, and you want 3 dots after it. So if we print it out now, if we did, for example, system.out.printf. Actually, I should probably just go ahead and do it over here. So if I did dot for f over here, let's see what gets printed out. Oh, doesn't want me to do it. Can't convert it integers to f's. So d. Yeah, I'm dealing with integers there, so it won't let me do that. If I do 3, this will let me do 3 spaces for the digit, essentially. So notice that basically that you've got 1, 2 digit. Then over here you've got 2 spaces. So you've got 1, 2, 3 spaces for the 2, 1, 2, 3 spaces for the 4, 1, 2, 3 spaces for the 6, 1, 2, 3 spaces for the 8, 1, 2, 3 spaces for 10. Everybody see how there's 3 spaces there? If I did 2 spaces, and see now there's 2 spaces. All right. So, and you can do multiple things. So here, for instance, you can have as many of these as you want. So %d, this means I'm expecting a decimal number, okay? This is an integer value, so they use d for integer. So this is why I don't introduce it in the first place, because it uses weird things. You want to use a d for an integer. %f for floating point numbers. So as I mentioned, it's like a little sublanguage within Java. So if I put d here, then I just want the decimals, however many spaces it needs, and just this number of spaces it needs. So if I just put in $d there, it just prints out the numbers, and they're all glommed together. If I put % space, it'll give me the entire number, and then they're all separated by spaces. If I tell it to do 3d, then then I say there I want 3 spaces for that number. if I start with 0, 8, it pads it with zeros, and it needs to be at least 8 wide. So if I do 0, 4, then look at what we get. We get 0, 0, 0, 2, 0, so 3 zeros and a 2, 3 zeros and a 4, 3 zeros and a 6, 3 zeros and an 8, 2 zeros and a 10, right? Because I said just start it with 4 with zeros. Then once you get to the number and print the number, and it needs to be at least 4 spaces wide. Okay? I mean, you can take it more if it needs it. Floating point, and then 0.2f to round it to 2 decimal places. So that's what's going on over here when I and again, you can have as many of these as you need. And notice it didn't print out a new line. It doesn't print out a new line unless you actually tell it to print out a new line with the /n. Okay. So let's go back to writing the how to do that. So we've written this bit that writes out a single row of characters. After the loop, we call print line to complete the line. So this printed out 2, 4, 6. So the next thing we want to do is we're going to, instead of putting it in main, we're just going to put it in a method. So we'll call this PrintRow, public, static, void. And typically if I have a void method, we'd like to give them, because their void methods typically don't do anything but print stuff out, we call it PrintRow. And then I'm just going to paste the code in there and call it to make sure that I copied everything over correctly, right? That makes sense. Being super cautious here, print the row, and I get the same output. Let's go back to just 4D over here. Okay. So now next thing we want to do is generalize this. Rather than printing out a row that does multiples of 2, let's do a row that does multiples of n, right? So rather than doing, right, it prints out multiples of 2 because we tell it to do 2 times n over 2 times I over here, right? This says right? We're replacing, the D says I'm going to get replaced with whatever's over here. So if I put 5 over here, it always would print out 5. If I did I, it'd print out 1, 2, 3, 4. So if I do, right, let me show those, right? If I just put I over here, it replaces the D, or the percentage for D with I, and formats it properly. If I put 5 over here, it'll print out all 5s, right? And we were doing 2s, right? Make sense? So here, if I decide to take in an int n, I can multiply it by I. Now notice I've got an error. It's not in my method. It's in main because now it takes in a parameter, right? So now I have to provide it with something. So I'm just going to provide it with 2. Make sure that's nothing changed, right? Same output as we had before. But now I can provide it with something like 10, and now should do 10, 20, 30, 40, 50, 60. So now I've made it more generic. All right? And so now you can probably guess how we're going to do a multiplication table. We're going to print out, in order to print a table, what we'll do is that we'll call this with the argument of 1, then the argument of 2, then the argument of 3, then the argument of 4, right? I can call this multiple times, right? Print row 9, right? But why don't we write a method that will do something like that? So public static void print table, right? And let's see how they want it. So we'll just grab another loop, and we're gonna, we'll do another loop in the main method first before we start putting it into a method itself, right? What we'll do is we'll create another while loop or for loop. For int I, we're gonna start at 1. I is less than or equal to 6. So all I is numbers 1 through 6. And what we're going to do is we're going to print row I. So they use a while loop in the book. I'm going to use a for loop. So I've got 1, 2, 3, 4, 5, 6 over there. Make sense to everybody? And now I'm just going to throw this into the method I wrote. And now the question is, I can make this even more generic. I can ask it how many rows I want. Right? I can put over here, oh, how many rows do I want? I would like to maybe print out this many rows. And then I can put in rows over here, right? See how I'm making it more generic? I. We want i's rather than rows because rows would be the same number each time. Rows doesn't change, i's does. So now we call this print table 10, and now it should print out 10 rows. And we can just keep building it on like this, right? Adding more and more features to getting to make it more and more versatile. Okay. The other thing we can, so let's see. So they went into the for statement. So the other thing that I want to that we should bring up that's not on the exam, but it's worthwhile knowing about because you'll see it here and pretty much never see it again, is the DoWhile loop. So while and for, they're pre-test loops is one way of looking at them. They test the condition before they run, right? Right, and that makes sense. You want to run it if this is true. A DoWhile loop is kind of the opposite. It tests it after it runs. You do this while this is true. So here's an example. So where basically this will keep reading input until it's valid, right? So system in is equal to new scanner system out in, boolean okay. So notice how the format for the DoWhile loop looks. It starts with a do statement and while it's not okay. Okay? So enter a number. If the next number, so in dot has next double. So has next the has next function are kind of useful. Has next double says is the thing that the user entered a double. And we're going to use that. And there's a useful function for like when we read files. We're using has next line, which tells us is there another line to read in this file. Has next double lets us know is there another double upcoming. If it is, then that's okay. Otherwise, false will want to skip over we want to read what they have and print out system.er.println. Word is not a number. It seems complicated, as it says, it's complicated. It's only 3 steps. Display a number, check the input, display an error, and start over. Read the input. That's very interesting, by the way, displaying an error. So just to show you, you ever wonder how it spits out an error at you? Well, you're using system.out.println. The computer, to spit out errors at you, will use system.er.println. You can print out. And notice that it's red text. You can print it out. Now, mind you, you shouldn't really use this as a way to color your text. That's kind of a bad idea. Because out and they'll fight with each other to see who can print out a line first. So if has next double is true, right? So what this does is basically, as I mentioned, right, what it will do is checks is the next thing to read a double. If it is, then it'll exit the loop. But notice that what it does is that it does the action of reading in something before it tells us, whether or not it's to continue. So DoWhile loops you're probably not going to use because most of the time you can just use a while loop or use a statement before the while loop to do it. But again, to know they exist is very useful. Okay. The last thing is, I think we mentioned we haven't really talked about infinite loops yet, other than in a theoretical perspective. So let's create a new class called, let's call it enter the right? Public static void main. So here's an example of an infinite loop, right? This is the most basic infinite loop, while true. Right? And if I run this, it's going to run forever. Right? Until I manage to terminate it somehow, which hopefully I can do by hitting the terminate button. Otherwise, sometimes you might have to force kill the computer or the process, which is rather annoying. But essentially, it dedicates all its resources to printing out a something while the statement is true. So now that may seem stupid, but a lot of times, sometimes later on, you might want to write a while true statement. So let's go ahead and, so here's an example. A lot of times you can use, so there's a statement that breaks out of any loop. Now, most of the time, I don't like using the break statement. Instead, you should use a Boolean statement to break out of a loop. But a break statement is pretty useful. So let's go ahead and create a scanner. In is equal to new system.in. Sorry, scanner system.in. Okay. While it's true, in dot next line. So this one's going to be fairly simple. Sout input. If word dot equals, right, to check for, we use dot equals to check for words. If word dot equals please break. So notice that's a keyword. That means if it's a keyword like if or true or break, you can't use it as a variable name. There you go. So input. If I put in A, it'll say didn't say the magic word F. If I do put in please, it'll stop. And what break does is that it breaks out of the innermost loop it's in. If this was a nested loop, it'd only break out of the current loop, the innermost loop it's in. But a break immediately kills a loop. Okay, break immediately kills a loop. The other keyword, which is continue, like this one, what it will do is that it will continue on to the next iteration of the loop without stopping. It just stops that current, it kills the current iteration of the loop, right? So it's like a mini break. It doesn't break out of the loop, it just continues on to the next iteration. And I rarely use it, so I'm not really going to go over it too much more. But they exist. And as it mentions over here, break and continue are much more powerful, but they make your code difficult to debug. Yes? What? Yeah, pass is a bit different, but Python has break and continue too. Okay. And as noted, that you don't really need them too much. All right. So now there's other types of infinite loops that are way more nefarious, and much more typical, and they're accidental in loops. So public static void oops. Right? This is something that I do this all the time, especially if I'm not paying attention. So say I want to write a loop that counts numbers going down, and I think I've showed this off, but it's worth reiterating. 10 I is greater than or equal, so I is greater than 0. And your instinct here is to just type I++, because you do that all the time when you do a for loop, right? You do the initialization, you do the condition, and then you go I++, right? Except here, if I want to count down, I should be going, what should I be doing? I should be doing I minus minus. But typically here, So here, right, and I've talked about this when I was talking about overflow. It's gonna, oops, I'm not actually calling it, so terminate. So let's go ahead and run, oops. So now, right, it will keep counting up until it overflows and goes to negative, which is close to an infinite loop, but won't actually be infinite. In Python, this would be infinite because Python doesn't care. All right. So with that said, I think it's time to take a break, and then I'm going to go over the practice exam, okay? And then we'll do one more exercise in class with the remaining time we have.